Good morning, students. Today we are going to see the next lesson, which is electromagnetic waves. These electromagnetic waves, we are going to see that they are the combination of electric and the magnetic fields. New term that is called as a displacement current. Okay, so displacement current and Maxwell's correction to the Ampere circuit law. We already know this Ampere circuit law, is it not? And that Ampere circuit law, we are just going to write it in the mathematical form as integration of E dot dl is equal to minus d phi by dt. That is Ampere circuit law. Okay. Now this can also be written as, instead of this phi, we're going to write it as integration of b into ds. Okay, so we are getting it as minus d phi divided by dt into integration of b dot ds. Clear? And next is, this is said to be the electric field, and this is a variation of magnetic flux, and this is variation of magnetic flux in the region. Okay, so this is variation of magnetic flux, and this is a changing of magnetic flux in the region. Clear? So this is the first equation which you have to know in this. So integration of E dot dl is equal to minus d phi by dt, which is equal to minus d phi by dt into b dot ds. Clear? Next is, same way as integration of E dot dl, this can also be written as B dot dl. Okay, so B dot dl is also equal to what? Minus d phi by dt. Same way, instead of this d phi by dt, I'm going to write it as B dot ds. So we are getting minus d dou phi divided by rho t into integration of B dot ds. Okay, and instead of this B dot dl, E dot dl, same this. Okay, this is also the same step. Here this is said to be the magnetic field because we are included with the term B, is it not? So this is said to be the magnetic field. This is as usual the variation of magnetic flux, and this is a changing of the electric flux. Okay, clear with this? So this is the variations of the magnetic flux in accordance with the Ampere circuit law. So phi is equal to E dot dA. This is a general formula. Now to remove this integration, we are writing as E into A. Okay, E into A, which is equal to Q divided by epsilon naught. This is according to Gauss law. Okay, so this Gauss law we have already studied in the first lesson itself, that which includes the between the two parallel plates. Between two parallel plates, this formula is E phi is equal to EA is equal to Q divided by epsilon naught. So here A is a capacitance of the parallel plate capacitors. So since we are considering a parallel plate here, okay, and these are the electric fields within this, okay, and the change in the flux is given by what? D phi divided by dt. Okay, now this d phi divided by dt, instead of this phi, if you are going to write this equation, q divided by epsilon naught. Okay, so it is q divided by epsilon naught. This epsilon naught, we are going to bring it to the front, so this becomes as 1 by epsilon naught into dq divided by dt. Okay, so what is this dq divided by dt? That can be written as I, because I is equal to rate of change of the charge. I is equal to dq divided by dt, is it not? And so instead of this dq divided by dt, we are going to substitute as I of d. Okay, and this I of d is equal to, when you need the value of id alone, okay, this you are going to bring it to the other side, so it becomes epsilon naught into this term, so it is d phi divided by dt. Clear with this? So from this we have got the value of I of d, where id is said to be the displacement current. Okay, id is said to be the displacement current. So id மட்டும் வேணும்னா என்ன பண்றோம்? Epsilon naught we are bringing this side, so epsilon naught into d phi divided by dt. This formula is very important regarding this I of d, and this formula is also important because you'll be using this in your problem. So E into A is equal to Q divided by epsilon naught, and also ID is equal to epsilon naught into d phi divided by dt. Next is, we are going to see the definition of this displacement current. The displacement current can be defined as the current which comes into play in the region in which electric field and also the electric flux are changing with the time. Okay, so whenever the electric field and the electric flux are changing, then the displacement current takes place in that region. Okay, so displacement current can be defined as a current which comes into play in the region in which electric field and electric flux are changing with the time. In other words, we can say that the change in the electric field take place, the displacement current is produced. அதான் எங்கெல்லாம் நம்மளுக்கு எலக்ட்ரிக் ஃபீல்ட் வந்து சேஞ்ச் ஆகுதோ அந்த இடத்துல நம்மளுக்கு டிஸ்பிளேஸ்மெண்ட் கரண்ட் இருக்கும் அப்படின்றது தான். ஓகே, ஸோ we have the equation here, integral of b dot ds, which is equal to mu naught into I. Okay, now instead of this I, I'm going to write it as the total current to be IC plus I of D. Okay, so where IC is said to be the conduction current and I of D is said to be the displacement current. Clear? So integration of B dot ds is equal to mu naught into I. Okay, this I can be written as what? IC plus ID. Clear? B dot ds is equal to mu naught I, mu naught into IC plus I of D. IC is said to be what? Conduction current and I of D is said to be the displacement current. Clear? Which means the total current is the sum of conduction current. Conduction current is what? IC and the displacement current. Clear? And now here we are having with the two condition. The first condition is when we have a constant current. So constant current அப்படினா then ID is equal to 0. ID வந்து 0 ஆயிடுச்சுனா then what? I is equal to IC. Okay, when you have the constant current then I is equal to IC. Clear? Then between the plates the conduction current IC is 0. So between the plates வச்சிருக்கும் போது IC வந்து 0 ஆடும், அப்ப I is equal to what? ID. So I is equal to ID. Clear with this? So constant current அப்படினா எது 0 ஆடும்? ID will become 0. So we have IC is equal to I. Okay, when you have between the plates, so between the plates அப்படினா எது 0 ஆடும்? நம்மளுக்கு conduction current 0 ஆடும். So we are getting ID is equal to I. Clear with this two conditions?